Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about polynomial inequalities. Our to-do list. First, what is a polynomial inequality? That's a really good question, right? It's kind of a big phrase. And how do you solve them? That's the next thing we discuss. We'll give you some tips, kind of a method, some steps to follow, and then we'll do a worked example for you. I'll also put the timestamps for each of these parts in the video description in case you want to skip ahead. Let's move to our first thing. So what is a polynomial inequality? Well, a polynomial inequality is kind of like a polynomial equation, except you have the presence of these inequalities, these four types of inequalities. So you have less than, you read them from left to right. So less than, if it opens up to the left and it's greater than or equal to, and less than or equal to. So these are polynomial inequalities. We have a polynomial, and then we have an inequality, and we have a zero on the left-hand side. And that's about it. It's not really too complex. But you might be asking yourself, what does some polynomial less than zero actually mean? So let's discuss that. What does it mean to have f of x, for example, less than 0? Well, really it just means where's the function below the x-axis. So if it's below the x-axis, then f of x, or in other words the y, so f of x, remember, is the same thing as y. So where the y is 0, the function's below the x-axis. So in other words, it's below the x-axis. So the area below the x-axis is down here in blue. Below the x-axis is colored in blue. Above the x-axis, colored in pink. And the y values above the x-axis are positive. The y values below the x-axis are negative. So notice that the x-intercepts on the curve of the graph we're looking at, they separate the sections, the pink sections, from the blue sections. In other words, they separate the sections that are above the x-axis from the sections that are below the x-axis. We have our first x-intercept, and we can see that the function's above the x-axis. Between the next two x-intercepts, we see we are completely below the x-axis. Between the next two, we see we're above the x-axis, and then between the next two we're all below, and then from the x-intercept on the far right of the graph going forward to the right, we see we're completely above. So it's actually pretty helpful because we don't really care how far below the x-axis it is. We just want to know that it's below. Or if it's asking for where's the function above, we don't care how far above the x-axis it is. We just want to know that it's above the x-axis. So we can use this idea that the x-intercepts do some work for us. They split up the x-axis into intervals where the function is either all below or all above. And we know that at the x-intercepts, the function is equal to 0, or the x-axis. So that is actually really helpful. So we use that in our solution steps. So the first thing we do is we write the polynomial inequality in one of these four forms. So we've got all four of the inequality options here. And the important part is that you need to have all of the polynomial on one side, either all on the left or all on the right, and then you have 0 on the other. That's important. So the first thing you do if it isn't in that form is you write everything, you take everything to one side of the polynomial inequality. And as a side note, the polynomial inequality you can algebraically manipulate it just like you would an equation. The only things you need to remember is that I'm going to write this as a separate note. The polynomial changes direction if you multiply or divide by a negative number as you're doing your algebraic manipulations. So keep that in mind. So once we get everything to one side and have 0 on the right, I prefer the right, but you can do it either way, then we set the polynomial equal to 0 and solve for the x-intercepts. Then we use those x values that we just found, and we split up the x-axis into intervals, and then we test each of those intervals to see if they're either above or below. Sounds pretty straightforward, right? Well, let's try it out. First step, this is our equation. Solve 2x squared plus x greater than 15. So first we need to get everything to one side. So let's take the, that's not what I wanted. I can't write with a highlighter, right? Let's take the 15 to the other side. We do that by subtracting 15 from both sides. And what we're left with is 2x squared plus x minus 15 greater than 0. All right, now the function is in the form f of x greater than 0. So we're good. Let's move on to the next step. Now we set the polynomial equal to 0 and we solve. So we're going to have to factor this. We could use the quadratic equation, but we can probably factor. And if we're factoring, we're going to guess this is going to turn out to be something that looks like that with two factors. We know in this first spot, these first two spots, we're going to have an x, and those two things multiplied together to give us 2x squared. So let's try for 2x and x. Let's see if that works. And we know in these last two spots, here we're doing the kind of the guess and the check method. These last two spots, we need to have the two things that are there need to multiply together to give us negative 15, which you see in this last term, negative 15. So our options are 15 and 1, with the appropriate negative, or 5 and 3. Those are the options, and one has to be negative, one has to be positive. So let's try the negative 5 and the positive 3 right here. All right. If we multiply this out, if we just check 2x and x give us x squared, negative 5, positive 6 gives us the positive 1x, and then negative 15, perfect. We guessed it right. So now we just take both of these and we solve each of them separately. So we have 2x minus 5 equals 0. We can add 5 to both sides. That gives us 2x equals 5. Now we can divide by 2. And forgot to cross out the 5 there. And I get x equals 5 halves. So there's one x value. Let's see what we get for this other one. It's always so hard to choose a color. X plus 3 equals 0. Let's subtract 3 from both sides. And our negative 3 goes away. We're left with x equals negative 3. So now we have two x values. X equals 5 halves and x equals negative 3. Those are our two x-intercepts. So let's write those down. 5 halves. Wow, it's not a very good 5 halves. And negative 3. Yes, I remembered those correctly. So now we have intervals. So our x-axis, remember, has 0 here, the positive values here, negative values here. So if we're coming from the left, we'll have negative infinity. What's the first thing we come up against? Well, we come up against negative 3. And we're not going to include negative 3 because we want strictly greater than 0, not greater than or equal to 0. So negative infinity to -3, and then we have -3 to positive 5/2, and then 5/2, or 2.5, to positive infinity. And again, this is 2.5, in case the 5/2 is throwing you off. So there we have three intervals. And we know that if we graph this, that the left section, -infinity to -3, would either be all above the x-axis or all below the x-axis. And the same with the other two intervals. But we don't know if they're up, above, or if they're below. So we can just test. We could also graph, but we can also just test. So here are the three intervals that we have. -infinity to -3, -3 to 5/2, and 5/2 to positive infinity. So let's just pick a value in the interval -infinity to -3. Let's just pick -4. It doesn't really matter. We can pick any number and plug it into the function. We wrote the function over here just as a reference. So let's plug it in and see what we get. F of -4. What is f of -4? So we have 2 times -4 squared plus a -4 minus a 15. 32 minus 19, that gives us 13. That's where my 13 was coming from. And that is a positive number, right? Positive. So this is a positive interval. Let's keep that in mind. Positive interval, so -infinity to -3, the function is above the x-axis because we got a positive number when we tested. So let's check the interval -3 to 5/2. Let's pick 0 because that's an easy number to pick, and I like picking easy numbers to evaluate. So we get 2 times 0 squared plus 0 minus 15 gives us minus 15. So that is a minus section. So this area is negative. It's all below the x-axis in this interval. And the last interval, 5/2 to infinity, so that's 2.5 to infinity. Let's pick 3. If we plug in 3 here, then we have 2 times 3 squared plus 3 minus 15. So 3 squared is 9. 9 times 2 is 18. And we have -12, which gives us 6. 6 is a positive number, so this section is positive. So we went from positive to negative to positive. So it looks like this function, this polynomial, is a parabola opening up. So let's state our answer here. We were looking for where the function was positive, right? That was our goal. Where's the function positive? And of these intervals, we had the -infinity to -3 was positive, so let's write that down. So we can say -infinity to -3, and the last interval, 2.5 to infinity, or 5/2 to infinity. We could write these intervals are the intervals where the function 2x squared plus x minus 15 is greater than 0 or above the x-axis. So let's take this one step further. We just found this, right? We found where is the function 2x squared minus or plus x minus 15 greater than 0. But what if we changed it up? You know, I've given you one example here, but what would happen if I messed with this a little? Instead of having it greater than, what if I changed it? So what if I put equals? Where is 2x squared plus x minus 15 equals 0? Well, I graphed this function here for you. And let's throw in some markers here. So I'm putting in a vertical dashed line at the x that goes through the x-intercepts, -3 and 2/2. So that clearly gives us 3 sections. It gives us the section from negative infinity to -3. It gives us the section of 3 to -3 to positive 2.5. And it gives us the section from 2.5 to positive infinity. So you can clearly see these 3 chunks on the graph. Well, where is the function 2x squared plus x minus 15 equal to 0? Well, it's only equal to 0 2 spots at these x-intercepts. So we would write it's equal to 0 only at -3 and at 5/2, or 2.5. That's it. Well, where is this function greater than or equal to 0? Where is it above the x-axis or equal to 0? Well, we know where it's above the x-axis because we know that it's above the x-axis. Let's write these down because we figured them out, right? Here it's above from negative infinity to -3. It's above the x-axis. In the next interval, it's below from -3 to 2.5. And then from 2.5 on to positive infinity, it again is above the x-axis. And I can make this a little more visible by using my highlighter and highlighting blue in the area that's below, and I highlighted pink in the area that's above. So the blue area is below, the yellow area is equal to 0, and the pink area is above the x-axis. So where is it greater than or equal? Well, we know that it is greater than. Well, that was the answer we gave originally, right? Let's write that down. The answer we gave originally was from negative infinity to -3. We didn't include 3. And then from 2.5 or 5/2, should probably be consistent here, 5/2 to positive infinity. And we didn't include 5/2 or -3 because that's where it's equal. But now that we want equal, we can change these parentheses to brackets, because now not only do we have the intervals that it's above the x-axis, but we also have the points where it's equal to 0, which are the endpoints, -3 and 5/2. The brackets include the endpoints and the parentheses don't. So what about the last one? Where is it negative? Only negative, not less than or equal, but just strictly negative. Well, only in this middle interval. So we would write -3 to 5/2, or 2.5. And because it's strictly less than, we don't include the endpoints, because at the endpoints it's equal to 0, right? We do strictly less than, so it's parentheses here instead of brackets. So that's really it. That's all we have for polynomial inequalities. I think that covers everything. So you should have a pretty good understanding of polynomial inequalities at this point. Hopefully this was helpful. If it was, subscribe to the channel, give me a like, and thank you for watching.